Okay, so good morning, Daisy. We are talking about how you approximate a value on a curve using the equation of a tangent line, and hopefully by the end of the lesson, I can approximate a value on a curve using the equation of a tangent line. So you should be able to do this. We're going to see it in lots of different ways, and I'm sorry that it's just a worksheet. I think I might owe you answers from another worksheet. I'll get those put up hopefully later today. But the problems are better there than I could get, and I didn't have time to type up. So I want you responding to me in the chat. I'm starting the grade book hopefully today for semester 2. So let's get some participation by participating in the chat. I'm going to purposely zoom this out. Okay, so zoom it out a little bit more. Okay, so don't read the words yet, okay? So what does this look like a picture of? Tell me in the chat. Just looking at it, not thinking about it, what does that look like a picture of? Tell me what you think in the chat. Again, make sure you're helping me out in the chat so that I'm getting you participation points. Okay. All right. It definitely looks like a circle, right? I mean, if I zoomed in enough, it would probably be a dot, okay? Or zoomed out enough, it would probably be a dot. All right, so I'm going to erase that. I'm going to zoom back in, okay? And hopefully you notice as I zoom back in onto that thing, it actually has sides to it, okay? You can kind of see little tiny angles, like right here and right here and right here. There's a little bit of an angle. You hopefully see that there's little tiny lines, okay? But the whole idea is that it was supposed to look like a circle. Realize that I normally put this up here. Okay, now I can see everybody a little bit better. All right, good morning, Hector. All right, so I want to make sure that my layout is, yep, it's stuck there. Okay. All right, so this is technically not a circle. It's a 24-sided regular polygon. I have no clue how to pronounce that. I know it's Icosti something or other, okay? So in case you're on Jeopardy, it does have a technical name. All right. So when the number of sides become this large, the length of the sides becomes smaller. So the calculus definition of a circle, okay, is simply a polygon whose number of sides, approaches infinity and whose length of sides approaches 0. So that's basically what a circle is our sides we're getting more and more and more and more sides, and the length of the side is getting smaller and smaller and smaller and smaller. So a couple of places where you can see this in real life, and I'm sorry that it is acting, that is really horrible. Maybe it's because I've got the fan on. Let me go try to turn the fan off. Okay, let me switch this up. All right, hopefully the flashing stopped. Okay. It got warm in here, and so I turned the fan on, but I switched the lighting because the fan with the lights was driving me bananas. Okay, so the phenomenon occurs quite a bit in real life. Examine the guardrails on the side of the curving road. So if I zoom in on this, okay, and you're going to notice that they don't actually match the curve. They're actually all little lines, right? If I were to draw this on here, they're just little lines. And when I put those little lines together, they're just angled just a little bit more, but they kind of look like a curve, okay? So they're really a series of straight rails, and since the straight rail sections of railing are numerous, they appear to curve, okay? Another place where this takes place is a wooden roller coaster. It's built the exact same way. It's far too difficult to create curved wooden rails, so straight planks of wood are used when there are many of them, and they can simulate the curvature of the coaster's hills, okay? So the idea here is what's going on is that when we can create curves with lines, and that was the point of this. So if I get many lines together, we can create that curve. But I also we can get it's close enough to the curve where we can have that point on there, and that's that's where we can get a tangent line approximation. Okay. All right, you guys are going to help me with this part because we kind of already know a lot of this part. A tangent line is just a line, right? It's just a good old line. It's just a line. Okay. All right, help me out in the chat if we learned nothing else last semester. What two things do we need to write an equation of a tangent line? Please tell me in the chat right now. All right, we did learn something first semester. Good job, everybody. We needed a point and we needed a slope, okay? A slope and a point, okay? So to write the equation of a tangent line, there's a couple of different things that might happen. This is mostly review because we've done a lot of this equation of tangent line writing before. Our point, it could be a value like c, and then the y value is represented by plugging the c value into the function. Plug x of c into the function to find the point on the tangent line. To get the slope, you take the derivative and you plug c into it to get the slope on the tangent line. And watch what they've given you. They may have already given you the derivative. They may have already given you the point. You have to read the problem carefully, okay? And this is, as always, the point slope form of the line. Now my thing is delaying. Ah, there it is. So that little, what I boxed there is point slope form of the line. Good morning, Diego. And that is basically, we don't use y-intercept, we use point slope. You could replace your y's with the function, okay? You could replace them with the function there. All right, let's take a look at example 1. So in example 1, we simply need to write the equation of a tangent line. So they gave us a function for f of x. It's maybe a little bit more complicated than functions we had first semester, but that's okay. And then we're supposed to write a equation of a line at x equals 0. So the first thing I'm going to do is figure out what my y is, because I don't have point and I don't have slope yet. Okay. Good morning, Kobe. All right. So my point, I am going to plug in my 0. So f of 0 equals 3e to the 2 times 0 plus 5. All right. 2 times 0 is 0. All right, you guys ready for a chat question? What is e to the 0, or really anything to the 0 power? All right, it is in fact 1. So I really have 3 times 1 plus 5, which is just 8. So I know that my point is 0, 8. Okay, how am I going to get my slope? What do I need to do? Tell me in the chat. It could literally be one word. What am I got to do? What do I got to do next? What am I plugging in if I'm plugging in? And to find the slope, do I need to plug in? All right, so we already did plug into the original problem, right? This is plug into the original. So original gets us the point. Okay. What Stephanie just said is the derivative, remember, gets us the slope. So I need to take the derivative. And oh, good, we have one of our friends. If I'm going to take the derivative of that, what rule am I going to need? What rule am I going to need? Look carefully, because it doesn't go away just because it's second semester. Do I have a product rule? Do I have a quotient rule? Do I have a chain rule? What do you guys think? Ah, we have our friend, the chain rule. So my u value is going to be the 2x. I'm going to put that off to the side here. So u equals 2x, meaning that u prime equals 2. All right, so I'm going to rewrite my function. F of x equals 3e to the u plus 5. And I'm going to take the derivative of that function with the u in there. All right, what's the derivative of e to the u? Go. Either there's a huge delay or we don't remember, because that one should be quick. E to the u, it's the derivative of e to the u. That's the easy one, right? E to the u is like the mirror function, right? He looks in the mirror and he sees himself. Okay, so e to the u, I should have seen everybody on that one. And then the derivative of 5 is 0. So then I'm going to multiply by the derivative of the inside function, which is 2. And then we're going to replace. So f prime of x equals, I'm going to multiply these two together, 6e, and then instead of writing the u, I'm going to write 2x. Now I need to plug into that to get the slope. And by the way, if we're doing this on a test and I don't see you using any substitution, I'm assuming you're scanning your things through PhotoMath, okay? Because I should be seeing you, sorry, not use substitution, but I should be seeing you use chain rule. And I taught the chain rule with the use, so, which is a very unique way of doing it. So if you're not doing it that way, I'm assuming you are doing nefarious things. All right, I'm plugging in a 0. So 0 equals 6e to the 2 times 0. So I've got 6e to the 0, which we know is 1. So I just get 6. So I am now ready to write the equation of my tangent line. I'm sorry, I should have left you more space in there, huh? I ran out of space and I wrote fairly small for Mrs. Ballard. Okay, so my equation of my tangent line would be y minus my y value, 8, equals my slope, 6, times x minus 0. And you may leave it like that. If we're going to use this to estimate, we might do a little bit more with it, but this time it just wanted the equation of the tangent line. All right, are there any questions or concerns up to this point? All right, let's take a look at example 2. Our goal is to try to get through all 5 today. All right, so the derivative, and I have to, of course, get done by 11:40, so we'll see how we get. Got half an hour, we should be able to do it. The derivative of the function, so they gave us the derivative, so we already know the derivative. I don't actually have to do that work, okay? It is known that k of 3 equals 19. Write an equation of a tangent line to k when t equals 3. So the two things I need are point and slope. Which one of those things do I have and do not have to calculate? So what do I have? Do I have the point or do I have the slope right now and don't have to make any calculations to find it? Tell me in the chat. All right, I do in fact have the point, right? Because it's disguised right here. This is the x value, that's the y value, so that's point. I need to find slope. The good news is I don't actually have to do the derivative. I was given the derivative. All I have to do is plug that 3 in. Uh-oh, we better be careful though. So this one's weird. The t value is 3, so technically this was t, right? Look at what the equation is asking for, though. It's asking for y. Okay, so it's weird, 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 weird. Okay, so I'm going to write this as dy dt. And I'm going to say that I know that when t equals 3, I'm going to write t equals 3, comma, y equals 19. And I know that looks really weird, but I'm trying to be really explicit about what I'm plugging in there. So I've got 1/4. And then it says y plus 5. Okay, help me out in the chat. It says y. So what number am I actually plugging into this? Am I plugging into 3 or am I plugging in the 19? I want to make sure you understand. Again, make sure you're participating in the chat because I am going to start putting participation in this week. Okay. All right, it is in fact the 19 that gets plugged in because it told us why. That's why they had to give us the point ahead of time, right? Because we couldn't do that function without it. All right, so let's see what happens here. So we've got 1/4 times, let's see, 19 plus 5 is going to be 24. And then 1/4 of 24 is 6. So my slope is 6. Okay. All right, let's write the equation tangent line. So y minus my y value 19 equals my slope 6 times x. And I'm still going to write it as x, even though it was t's, because we're technically writing equation line, minus the t value, which is, or the x value, which was 3. Now, another way I could write it, I'm doing this on purpose because I'm trying to build us up to where we're going today, okay, is I could move this 19 to the other side, and I'm going to put it in a weird place. I'm going to put it in front. So I could add the 19 to the other side. And that's another way to write the same equation of a line, okay? All right, there was a few things left off. I was reading this just before class started, and let me just rewrite that. I'm talking about it, but I didn't want to, because I did not write it very clearly. Approximate values. Okay, so why do we want equations of tangent lines? What good are they? Okay, so tangent lines can help us approximate values of a function when we cannot easily evaluate the function. I'm sorry, I chopped this part off. So it says help us approximate values is what you need to put, is to help you at least understand that. Approximate values. All right, they gave us a picture here. So notice that the function f of x and the tangent line t of x to the right, it's to the left. Apparently I didn't copy and paste that well enough. When x equals 5, the tangent line t of x has the same value of f of x. So at 5, you'll notice that they have the exact same y value right there. They're crossing or intersecting. As at values near x equals 5, the tangent line t of x is near the graph of f of x. So this allows us to use t of x to approximate f of x near x equals 5. So for example, we could put in 5.1 and we would get really close. They'd be approximately equal to each other on that graph. All right, I don't know why there's so much space. So now we're going to use a chart, because the AP exam, you know, is famous for this. Okay, I don't know if it's famous or infamous, but it's one of the two. So we've got functions f and g. It tells us that differentiable is selected values of f, g, f prime, and g prime in the graph above. Ooh, let h of x equal f of g of x. All right, so whenever you see this, hopefully it does not strike fear in your heart, okay? When you see that, what do you think of? What rule do you think of immediately? Okay, what rule do we think on that one? So we saw it a whole bunch. I know you did. Ah, yes, we have a chain rule going there. Good job, everybody. Okay, you could almost memorize that one. We've used it so many times, right? So we've got to write an equation of a tangent line to h of x at x equals 4. Okay, see if we've remembered from the beginning of the lesson. What two things do I need to write an equation of tangent line? Please put it in the chat as fast as you can. All right, we do in fact need a point and a slope. Good job. So in order to get my point, I'm just going to plug into that function. So I'm going to start with the point, and I'm going to label it point for you here. Okay, I'm not going to use orange though. All right, so I'm going to say that I have h of 4 equals f of g of 4. Okay, so that means I'm going to take and go to my table, and I'm going to read g of 4, and I'm going to find the y value at g of 4. So I've got g going to 4. I'm reading a 5 off the table. Okay, now it says that I have to take 5 and plug it into f. So I'm going to go to my table. I'm going to go to f, and I'm going to go to 5, and I'm going to read the value off the graph, which is equal to -9. So my point is going to be 4, negative 9. All right, in order to get my slope, I need to take the derivative with the chain rule, right? So h of x, I'm going to rewrite first. So f of u, right? And I need to figure, I'm going to put my u off to the side. All right, so u is g of x. What's the derivative of u? What's the derivative of u right now? Tell me in the chat. And you don't have to get super fancy about it. Just give me the value. There we go. Nice, nice. Aren't derivatives better actually when we don't use all of the algebra in it? They're so much nicer, aren't they? So g prime of x. Okay, and then we're going to put these, so now I'm going to take the derivative, right? So h prime of x equals the derivative of f would be f prime of u, and then times the derivative of the outside, which is g prime of x. Then we need to substitute our u back in. So h prime of x equals f prime of g of x times g prime of x. Again, I should have left you more space. You do not need all the space you have for B. Okay, we need like 2 lines for B. So if you need to use some of the B space, you can. Okay, I'm going to keep going to the right here. Okay, so now I need to plug in this 4 to find the slope of 4. Okay, so h prime of 4 equals f prime of g of 4 times g prime of 4. All right, I'm going to erase my scribbles on my chart. So f prime of g of 4. So I'm going to go to g, and I'm going to read where it says 4, and it looks like I got 5. Says I need g prime of 4. So I'm going to go to g prime. I'm going to grab 4. It says that it's negative 2. Then I'm going to go to f prime. So f prime of 5 looks like I get 3. So 3 times negative 2 is 6. This is our slope. Okay, so I'm going to go ahead and write my tangent line under B because there's not a good spot for it otherwise. So y minus my y value, which is the negative 9, equals the slope, negative 6, times x minus the x value, 4. All right, the double negative is going to go positive, so we're going to make that a plus 9. Now, we are supposed to use the tangent line from part A, which is here, right? This is our tangent line. Okay. And we're supposed to use it to approximate h of 4.1. I don't understand why they gave us the same function. So we're going to go, well, probably because it's close to it, right? The tangent line should approximate that. So what I'm going to do is I'm going to move this 9 to the other side first. So I'm going to say y equals negative 9 minus 6 times x minus 4. And then instead of saying y, I'm going to call it h. So h of x, and I'm doing a lot of steps in here because I want to make sure you understand all the little pieces. I might not do all of that when I'm doing my homework. Okay, I might skip maybe this line here. Okay, what is your instinct telling you you need to do with that 4.1? Tell me in the chat. What do you think you got to do with that now? All right, good instinct, Jocelyn. Thank you for being specific. I like it. We're plugging it in for x. There really isn't anywhere else to plug it in, but we're going to plug it in for x. All right, so I'm going to squeeze it in here. H, and believe it or not, even though this is a decimal point, it usually is non-calculator because check out what happens. Look at 4.1 minus 4. That's not a hard thing to do, right? This is a minus sign in here. So h of 4.1 equals negative 9 minus 6 times 0.1. So negative 9 minus 0.6, right? Make sure my arithmetic is right. Okay, and so let's say negative and negative is going to stay negative, negative 9.6. So that wasn't so bad, I hope. I still got tons of time. Okay. I'm going to give you a few seconds there to make sure you're all caught up. Okay, let's take a look at example 4. Okay, so very similar, slightly different scenario. They gave me same ideas here though. Okay, so let f of x be a function. They gave me the derivative. Okay, so what is the derivative going to give me in the problem? Tell me in the chat really quick. What's the derivative going to give me? Awesome, 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 awesome. Okay, that's the answer to the question. So if we do go back, that I ask on test day, hopefully when we go back, okay, and we get to take our AP test and wear our matching shirts, okay, I will make sure, if nothing else, you all have a matching shirt this year, okay? Then that's the answer to the question. I usually take a picture and I say, what's the derivative? And you all are supposed to yell slope, okay? So hopefully I'll get to hear all of your voices doing that at some point this year. So containing this point. So I've already got point. Woohoo! We got to write the equation for the tangent line. Y equals f of x at x equals 1, and then use it to approximate. So if I've got point, I've got to find slope. So I'm going to plug those values into this guy right here, okay? So I'm going to use some funny notation again, but again, this is what you got to tell the grader what you're doing, okay? You can't just say dy dx equals and you plug in values for your number or for your variables. You have to tell it what you're plugging in for your variables, or tell them, not it. It's not a robot that grades your papers, unfortunately. It is actually a person, or a couple of people actually on the AP test. All right, so I'm plugging in the 1 for the x, and the -5 for the y. And on the non-calculator, they're not going to give you anything that's super hard that you would need like even double-digit multiplication for, okay? It should be fairly simple. So 3 times 1 is 3. -1 times 4 is -1 squared. So I get 3 over 1, which is just a slope of 3. All right, put it in the chat. Write your equation of tangent line in your chat. Leave it in slope intercept. Okay, so tell me what the equation of tangent line is. Let's see if you've got this. All right, they're looking good, everybody. I like what I'm seeing. I noticed Stephanie wrote a little different. Siobhan wrote a little different. Both are correct, okay? And they would earn full points. And where Stephanie's going with hers, if you look at her equation of tangent line, she's going to the estimate, the approximation. If you didn't have to do the approximation, we would want to write it like everybody else is, because you don't want to make a mistake. Okay, because there's anytime we move something, right, there's room for error, and we want to eliminate as much error points as we can on the test, right? So I'm going to go with you. Y minus the -5 equals the slope 3 times x minus 1, and that's going to go positive. Okay, I am going to do what Stephanie did because I do need to approximate. So I'm going to go y equals, actually I'm not going to write y. Instead of writing y, I'm going to take it back to f of x because they're wanting us to estimate f. So I'm going to say f of x equals -5 plus 3 times x minus 1. Hopefully you're understanding that you don't want to distribute that 3, right? If I had, look at this last one, if I had distributed that 6, how awful would this have been right here? That would have been awful to try to calculate. but it wasn't so bad because we didn't rush to distribute the 6. So you don't want to do those. You don't want to rush into distribution, okay? In calculus, it's better to go a little slower with your algebra because sometimes good things happen, okay, when we go a little slower, okay? All right, it says we got 0.8. So we've got f of 0.8 equals -5 plus 3 times 0.8 minus 1. Again, I would not have wanted to do 3 times 0.8, right? That would not have been pretty. So I would much rather leave it the way it is. So 3 times -0.2, that seems a lot better. So -5 minus 0.6, is that where we're at? And we end up with -5.6 as the estimate. How are we doing? I hope we're doing okay. This stuff shouldn't be too bad. Okay. Should be easy peasy lemon squeezy. My daughter's kindergarten teacher told us that. So for the past 7 years, I've used it. Someday I'll have her kindergarten classmates in class with me. Just a few years now. One of their siblings is in my Algebra 2 class right now. Okay. Actually, I have one in my, actually I have a set of brothers too that are a sibling or a classmate of Ellie's, but they didn't go to kindergarten together. All right. Let's do something with a word problem, right? Because you know the AP test is not going to be very explicit about things. So let's put this in a little bit of a context. So this is the last one we got to do. Let's remember back to Thanksgiving, right? And this is not my favorite pie. If it was me, I would cross this baby out and write apple on it. Who's with me? Who'd rather have apple pie than pumpkin pie on Thanksgiving? Who'd rather have apple than pumpkin? I know I would. This year, though, I didn't make apple on Thanksgiving. It was the first time. It was Andy's birthday. It was his actual birthday on Thanksgiving, and he likes French silk pie. He got into that. My kids won't eat pie. There's something wrong with them. But because pie is better than almost anything else. So, but he wouldn't eat it. So instead of French, I made French silk pie, but I also made a chocolate pumpkin pie, and my kids actually ate the chocolate pumpkin pie. I was shocked. So it tasted good. It was really like thick though. All right, but again, apple, Marissa and I are going to eat apple, and Casey are going to eat apple instead of pumpkin. If you like pumpkin, you leave it as pumpkin. Okay. All right. Cherry is good too. I like cherry too. All right, but my favorite, I'm sorry, you got me on a pie tangent, is rhubarb. Rhubarb is amazing. So if you've never had rhubarb pie, you should try rhubarb pie. Okay. So on Thanksgiving, a delicious apple or pumpkin pie is removed from the oven, has a temperature of 175. So you need to watch because they just put something right there that's important, okay? And it's hidden, okay? So the temperature of the pie at time t minutes can be modeled by this function. Okay, so they gave us the function already, okay? The temperature of the pie. So notice that it's already in derivative, right? It's already in the format of a derivative. So this is already the slope, okay? Use the tangent line to P at t equals 0 to approximate the temperature of the pie 4 minutes after being removed from the oven. So our approximating is 4 minutes after removal. What's our point? What point? We have the point. It's there. Tell me in the chat, what do you think the point is? Oh, Casey's like, it has something to do with 175. What's the X value though? Or the T value? Brianna, good job. Good job. Okay, so T equals 0. So I'm going to bring up this word. I think we've talked about it before. That's your initial condition. You want to look for that in everything. An initial condition is typically a starting point, okay? And it's usually has to do with a 0, okay? So do you see how it said, hey, we're removing it from the oven. Removing it from the oven would be times 0. Okay? All right. So we got the point. I need to find the slope. So this is actually the t value, and this would be the p value according to this problem. So I actually need to put the y value in. So dp dt when p is equal to 175. Actually, I could do, I want to be really explicit about this. I could say when t equals 0 and p equals 175, because they're actually asking for 0, right? So it's a negative 1 over 50, 175 minus 25. And again, this would be a non-calculator problem. You would have to do this without a calculator. And you don't always have to simplify, but with this one, it's going to get kind of nasty. So I would probably simplify it, because if not, that's your slope, right? And that'd be kind of ugly to work with. All right, so we've got negative 1 over 50, and this would be what, 150? 50 goes into 150 3 times, so it'd be negative 3 as your slope. I don't know why I went to the right when I could have gone down. I have tons of space, right? Okay, so we've got to write the equation of a tangent line. So I'm going to go, I always start y minus, because this is the way what I know, right? Y minus 175 equals my slope, negative 3, times x minus the x value of 0. Do I really need the minus 0 part? Do I need that? I don't really need that, right? So I could get rid of it as I write my next line. I'm supposed to use it to tangent line to P. So I'm going to change my y into P of t. I'm going to move the 175 to the other side by adding, and then I'm just going to say minus 3x. That's technically the equation. Why am I saying x? If I change it to t, guess what? I got to change this to t. Okay. I guess I could have left it p of x. All right, we've got to plug in a 4. So p of 4 equals 175 minus 3 times 4. So minus 12. And officially 175 minus 12 would be 163. And we would probably want to label it degrees Fahrenheit. Yeah, we should probably write a sentence, but I'm going to be lazy today. Okay, so that concludes what we're going to do for officially today, okay, for the synchronous part. Don't forget that paper tutoring service is out there. Somebody in 3rd period, I know you guys played with it. We played with it sometime in December, but because I can remember Marissa and Jocelyn asking questions to the people. Use it, okay? So they were using it on some of the word problems last week. Some of them used it, and they actually, somebody found, I think it was Noelle, she's like, it was awesome. They helped a lot. So not that I can't help. You guys know I can help, but you know I'm not going to be helping you at midnight, okay? So use that service, all right? So let's look at what the rest of today is. And I'm going to have to tell the joke myself because my son was getting ready. Only had 20 minutes to get dressed this morning because he didn't get up enough or early enough. And then, whatchamacallit, so he didn't do my joke for me. But I'll tell you a joke. Okay, let's go to, I want to go to Google Classroom. That's a new color. I got to fix the color because I can't handle the pink. It's kind of close to red. All right, it's a frog because somebody in my 6th grade class said frog was their favorite emoji. So I used a frog this week. All right, so today we just did the live lesson on 4.6. And yeah, we skipped over 4.5 and 4.4. So I'll talk more about those maybe on Wednesday, what we're going to do with those, okay? All right, you're going to work on, you're going to make sure you turn in note 6, okay? Make sure you get them all fixed up and turn them in. And then make sure you work on 7, okay? And it is an old school worksheet. You want to print it and write on it, that's fine. Or you write on your own paper, either is fine. Or you can write on it, if you have the ability to write on it in Cami, you can do that too, okay? All right, did you see what's coming up? There is only one more lesson, okay? My goal Wednesday is to keep it to 20 minutes if I can. Okay, so I might do part of the lesson Wednesday and then maybe do the second half on video or something. And then I will have a review out there as well. So if I can get that review out there later today or tomorrow, I will post it so you can start looking at it. Okay, and I don't know if I'm going to do progress checks or if I'm going to write my own this time. I haven't decided. Okay, it will be one or the other though. So next Monday we're going to be prepared for a test and see how this goes. Okay, so if you're not caught up, you need to catch up fast, because for a while that test is going to be 70% of your grade. Okay, so you want to make sure that that's a good 70% of your grade on this first time around. Okay, all right, you ready for the joke? I'm going to tell it. You ready? So why couldn't the angle get a loan? So why couldn't the angle get a loan? Its parents wouldn't co-sign. That was bad, wasn't it? But you guys would understand it because you know trig. Co-sign, and they have to co-sign the loan. And it was an angle. That was a good one. Thanks, Casey. Thank you. Andy had one about a duck this morning, so hopefully he'll record it and we can do 2 jokes on Wednesday maybe. All right, so I'm going to let you guys go ahead and go. It is time. So get up, move around, do some whatchamacallit, do some get up and move around, and then come back and sit down and get working through this assignment. Okay. All right. Have a great day. I will see you on Wednesday. Okay. Bye, Brianna. Okay. Let me stop.